diesel engine has been in use for almost 100 years. But on the roads, it's tended to be used mainly in lorries, buses and taxis. The public image of the diesel engine has been that it is noisier, smellier and smokier than its gasoline-burning equivalent. But modern technology is transforming this image. Today, there are many motor cars powered by quiet, clean, high-speed diesel engines, and they are achieving far higher levels of fuel economy than are possible in gasoline engine vehicles. To appreciate why this change has occurred, we need first to understand how the diesel differs from the gasoline engine. Both diesel and gasoline car engines use the same four-stroke cycle: induction, compression, power, exhaust. But in the diesel, the induction stroke draws only air into the cylinder, not a fuel-air mixture as in a gasoline engine. This air is then highly compressed, which heats it to around 550 degrees Celsius. Towards the end of the compression stroke, the diesel fuel is injected into the combustion chamber at very high pressure, over 350 bar. The atomized fuel mixes with the hot air, and ignition occurs spontaneously. Hence, the diesel is also known as a compression ignition engine. No spark is required. The expanding combustion mixture now forces the piston down, producing power. The exhaust stroke drives the spent gases out of the combustion chamber. The diesel's increasing popularity with motorists is based on its economy and reliability, both consequences of the compression ignition principle. Take reliability first. To achieve combustion, we saw that it was necessary to compress the air a great deal to raise its temperature. The degree of compression, or compression ratio as it's called, has to be much higher than for a gasoline engine. So the diesel must be built to withstand these high pressures, and this tends to make it more rugged and reliable. In addition, the fact that no spark is needed means that the engine is simpler. There's no carburetor, no electrical ignition system, distributor, spark plugs and so on, which are often the cause of problems in gasoline-driven vehicles. Now let's look at fuel economy. At full power, there is little difference between diesel and gasoline engines. But as the power is reduced, the diesel starts to become more efficient than a gasoline unit. This is because power is reduced by decreasing the fuel flow into the engine, which lowers the proportion of fuel in the combustion mixture. This improves the efficiency of the engine, particularly at the lower speeds common in city driving conditions. The gasoline engine, on the other hand, reduces power by throttling a virtually constant mixture of air and fuel. The other big saving comes from the rapid warm-up of the diesel engine when starting from cold, as compared to the gasoline engine, which can take up to 15 kilometers to reach its optimum fuel economy condition. When many people only use their cars for short urban journeys, this can make a big difference. To benefit from the inherent efficiency of the diesel engine, it is important that the fuel system delivers exactly the quantity required according to engine conditions. The main components of the fuel system are the fuel tank, a filter, the pump, injectors, and a return pipe to the fuel tank. At the heart of the system is the pump, usually a rotary pump, and it's an expensive piece of precision engineering. It has to deliver a precisely metered quantity of fuel to each cylinder at pressures of over 350 bar at exactly the right moment on the compression stroke. Often the fuel must be injected within less than 1/1000th of a second. It's forced into the cylinders via the injectors just before the piston reaches the top of the compression stroke, and it enters as a finely divided or atomized spray. When these fuel droplets encounter the hot air, they start to vaporize, and after a short delay, this vapor ignites. This further increases the temperature, and the flame spreads through the fuel-air mixture. To be efficient, this combustion needs to be rapid. Since the rate depends largely on the ease with which each fuel droplet can find fresh oxygen, various designs have been produced to achieve rapid but controlled mixing of fuel and air inside the cylinder. This swirl not only supplies fresh air to each burning fuel droplet, but also helps sweep away the combustion products which tend to hinder further burning. In direct injection, or DI engines, this swirl is created by careful design of the inlet ports, which give the air a swirling motion as it's drawn into the cylinders on the induction stroke. Unfortunately, the swirl created is not very strong. To increase mixing, we have to use multi-hole injection nozzles and high-pressure injection pumps, both of which add to the cost of the engine. And because the injector is mounted directly in the cylinder head, the valve size is also limited, and this restricts the useful speed range of the engine. These limitations have so far restricted the DI engine to use in commercial vehicles. The indirect injection, or IDI engine, on the other hand, relies on passing the air at high speed from the main cylinder into a swirl chamber, or pre-chamber. This gives a high rate of swirl and allows the use of single-orifice Pintle nozzles with relatively low injection pressures. Large valves can be used because the injector is positioned in the pre-chamber to one side of the cylinder. This allows the IDI engine to breathe more easily and operate over a far wider speed range, the range needed for passenger cars. The IDI engine is also quieter. This is because the Pintle nozzle can be designed to vary the rate of fuel injection, and so smooth out the rate of increase of combustion pressure, the source of characteristic diesel knock. Development of the IDI concept to its present level means that car drivers can now obtain diesel engines with lower cost injection equipment that provide a wide speed range and low noise levels. There are two basic designs of IDI engine. The swirl chamber is used by virtually all manufacturers. Combustion is completed in the specially shaped cavities in the piston crown. The pre-chamber is still favoured by one major European producer, and this relies on both swirl and turbulence in the throat to promote mixing while providing very low combustion noise levels. Both designs use a glow plug to preheat the combustion air to aid cold starting. The IDI engine does have one disadvantage. The combustion gases pass through the throat between the pre-chamber and the main cylinder at very high speed and high temperature, and a considerable amount of heat is lost through the throat walls. So the IDI engine is somewhat less efficient than its DI counterpart, and much research is being directed towards the development of a high-speed direct injection engine which would be satisfactory in cars. As well as providing good fuel economy, diesel cars require very little servicing. The air filters must be kept clean, as any obstruction will reduce the quantity of air entering the cylinders. In dusty conditions, the air filter should be changed more frequently. The oil and oil filter should also be changed regularly, usually at 8,000 or 10,000 kilometre intervals. The fuel filter should be replaced as specified by the engine manufacturer. Rotary pumps are self-lubricated by the fuel and should require no maintenance or adjustment throughout their working life. The modern diesel car can provide high standards of performance and economy. It meets current and proposed exhaust emission regulations in Europe without resorting to expensive catalytic systems. The initial cost is higher than for a gasoline engine because of the complex injection pump and the need for more robust components, as well as for a heavy-duty battery and starter motor. This will be offset by the lower running costs, particularly when drivers use the vehicle for a lot of short journeys. The principal elements of the diesel engine are the combustion chamber, fuel pump, injectors, and filter. Together, these high-precision components ensure that the diesel is an economic, environmentally acceptable and practical alternative to the gasoline engine for vehicles of all sizes.